Hi everyone, this is SD Guzman and welcome to my YouTube channel. For this tutorial video, we are going to discuss the second part of the rectilinear kinematics, the erratic motion. Before we start, if you haven't subscribed yet, please click the button and subscribe because every week I upload different full lecture videos. So, for today's video, let's begin. Whenever a rigid body or a particle has an erratic or a changing motion, yung kanyang velocity, position, and acceleration cannot be described by a single continuous mathematical function along the entire path. So, yung erratic motion na tinatawag, it occurs whenever a motion parameter, yung motion parameters natin na yun yung position, velocity, and the acceleration is not continuous or yung kanyang mathematical function has jumps or sharp bends. In real life situations, marami tayong example ng erratic motion. Like for example, when we are driving a car, so along the travel natin, hindi diretso yung, or hindi continuous yung kanyang motion. So meron diyang magsa-stop tayo, meron diyang magbe-brake, or magsa-start na ulit, depende sa traffic. So that's one example of an erratic motion. In erratic motion, when solving a problem, it is better to represent the motion using a graph. If we can create a graph of the motion that relates any two of the motion parameters, the position, the velocity, and the acceleration, then we can use this graph to create another graph subsequently or graphs in order. Relating to variables or motion parameters, since those variables are related with a differential equation such as this three, yung v is equal to ds over dt, a is equal to dv over dt, a ds is equal to v dv. So, yung mga equations na yan or yung mga formulas na yan, dyan lang din tayo iikot sa pag-solve natin sa problems from the erratic motion. We have two sets of graphs, yung tinatawag natin as the ST, VT, and AT graph. Yung S, that's the position, V, velocity, A, the acceleration, and T, yun yung ating time. The second set of graph, we have what we call the VS in the AS graph. So, with respect to position naman tayo. V, velocity, VS, and A, acceleration, AS graph. So, that's the two set of graphs na ating itatakal dito sa rectilinear kinematics erratic motion. Paano ba tayo mag-create ng iba't ibang types of graph when it comes to erratic motion? So, let's start with the ST, VT, and AT graph. Here's an example of an ST graph. This is the S or the position and the time yung nasa horizontal axis natin. This is ST graph. We can see these points here or this slope. Ayan, itong slope na to, and this slope. Yan yung ating velocity. So, alam na natin yung formula na V is equal to ds over dt. Now, yung slope na yan, yan yung ating velocity. Let's say, for example, this is the slope 1 or V sub 0, V sub 1, V sub 2, and V sub 3. Lahat yan yung ating velocity. Lahat ng slope na makikreate natin along the ST graph, siya po yung ating velocity. And yung velocity na yun ngayon, out of the ST graph is, yun yung bago mong i-consider as the vertical axis. And yun yung gagawin natin na VT graph. So, let's say this is ds over dt lang din. ds over dt, time is equal to t1. And itong v2 natin, ds over dt din as the time is equal to t2. And yung ating v3 is the ds over dt where yung time niya ay yung t3. Now, from the ST graph, mabubuo natin yung VT graph. And here's an example of VT graph. Yan. So, next naman, paano naman tayo mag-create ng AT graph given a VT graph? Here's another example of VT graph. Makikita ulit natin ang points na to. Same as sa process na kanina lang din, mag-create tayo ng VT graph from the ST graph. This time, gagawa naman tayo ng AT graph from the VT graph naman. So, these points, ayan, itong slopes na to, slope is slope. Yan naman yung ating acceleration. So, yung slope ng VT graph natin, siya yung acceleration, whereas yung A is equal to dv over dt. Considering this is A sub 0, A sub 1, A sub 2, and A sub 3, whereas A natin is equal to dv over dt where yung time is equal to 0. A1 natin is equal to dv over dt din, yung time is equal to t1. A2 natin, dv over dt, yung time is equal to t2. And lastly, yung A3 natin is also dv over dt where yung time is equal to t3. Now, from the VT graph, kapag nabuo na natin yung slope, and yung slope na yon is equivalent to acceleration, magagawa na natin ngayon yung AT graph. Ito ang ating AT graph. Now, reversely, pwede naman tayo mag-create ng VT graph at saka ng ST graph given only the AT graph. For example, we have this AT graph. Itong nakikita natin na shaded part, ayan, ito. Ito yung tinatawag natin as the delta V. So, itong area na to is equal to the delta V or yung ating change in velocity. So, change in velocity is equal to the area under AT graph. And now, para makabuo tayo ng VT graph out of the AT graph, itong delta V or yung change in velocity natin na makukuha from the AT graph ay i-add natin sa V sub 0 or yung initial velocity natin. Here is the VT graph. So, ito, pag ilalagay mo na siya sa VT graph, ito na siya. Yung small increments na yan, idadagdag mo sa V sub O, and then sa V sub 1, sa V sub 2, hanggang makabuo ka ng slope or ng another graph from the AT graph. Ito namang graph na to is the VT graph. Now, from the VT graph, kung gagawa naman tayo ng ST graph, same process lang din. So, here's another example of VT graph. So, makikita natin itong shaded part na ito. This is now the delta S or the change in position. So, ayan. Change in position is equal to the integral of V dt. So, dito natin yan makukuha. Ito po siya. The displacement is equal to the area under AT graph. And now, dahil alam na natin yung change in position from the area of the VT graph, paano natin siya gagawing ST graph? So, same process lang din from the AT graph to VT graph kanina. Etong part na to, the small increments ulit na equivalent sa area ng VT graph natin, add lang natin starting from the position sub 0, position 1, position 2, position 3, hanggang sa makabuo na tayo ng another line to the ST graph. So, that's how we do the ST graph. But, as we can see, itong mga formula na nakikita natin dito, already derived na yan. Lahat ng formula na yan is nanggaling lang din dun sa tatlong basic formula natin kanina. Yung V is equal to ds over dt, yung A is equal to dv over dt, at saka yung ADS is equal to V dv. So, dun lang din papasok. When we are solving problems na, dun pa rin tayo ikot. So, pinapakita lang natin kung paano nabubuo dito yung mga graph from another graph. And next, we have the VS and the AS graph. This is an example of an AS graph. If the AS graph can be constructed, then ibig sabihin, yung points natin for VS graph can be determined by using the equation, yung equation natin na VDV is equal to ADS. Ayan, sa equation na yan. Integrating this equation, pag in-integrate natin yan from the limits from initial position, initial velocity to the final position and final velocity, ito yung mabubuo natin na formula or the equation. So, ayan yung ating area under AS graph. Ito yan, yung equation na yan or itong formula na to. But, as I have said, huwag tayong malilito kasi itong mga equation na to, itong mga formula na to, ay nanggaling lang dun sa 3 basic equations natin. Same process, parang ganun sa kanina, yung makukuha natin na value dito ng V1. So, ang sasolve kasi natin dito is yung V1 to create V as a graph, VS graph. Now, yung V1 na yun, parang ganun sa kanina, yun yung nandito sa part na to na idadagdag natin sa V sub 0, padagdag na padagdag into successive points hanggang makabuo na tayo ng graph for VS. And vice versa, if we have given a VS graph, pwede naman nating ma-determine or ma-create ngayon yung AS graph from the VS graph. Now, etong ginuguhitan ko ngayon, itong slope na yan is the acceleration. So, using again the formula, etong formula na paulit-ulit nating ginagamit, binaba lang yung ds dito, yung A is equal to V times dV over ds. yung slope natin dito sa VS graph, this is S. VS graph is equal to the acceleration. And pag nakuha na natin yung mga values na yon ng slope or ng acceleration natin using the equation given a graph, makikreate na natin ngayon yung tinatawag natin na AS graph. And now, to better understand the principles, let's apply it to 4 sample problems. So, let's take example number 1. Example number 1, problem. The ST graph for an object is known. So, itong figure na to dito, yan yung ating ST graph. So, ST graph for an object is known. And from the data, create the VT and AT graph. So, given an ST graph, gagawa tayo ngayon ng VT at saka ng AT graph. For the motion, we have the time given 0 less than or equal t less than or equal 40 seconds. And for 0 less than or equal t less than or equal 30 seconds. So, ito yung mga parts or mga time na i-consider natin. The curve, ito yung curve natin. Ito po yun. So, the curve is S 0.40 square. Yun yung equation ng unang line natin. And then, it becomes straight. Dito sa part na to, naging straight na raw siya. So, kaya natin siya tinawag na erratic motion kasi sabi ko nga sa definition kanina, yung erratic motion, hindi siya madidefine with a single continuous mathematical function. Kasi unang-una, dito sa example problem number 1 natin, dalawa yung equation na given. We have 0.40 square and yung equation ng ating line, ito yun, we have 24t minus 360. Nagbago yung kanyang mathematical function. Ibig sabihin, yung motion din, nagbago. Okay? And yung motion, re-represent natin with the graph and with the functions or equation. Okay? So, gamit itong given na to, kailangan tandaan natin, take note that whenever we are solving erratic motion problems, so, hindi natin is pwedeng isolve ng yung isang buong graph ng isang rekta. Kailangan hati-hatiin natin siya to create the graph. Now, let's start with the VT graph. Ngayon, ang una natin gagawin, ang una natin resolve is yung nasa part na ito. Ito. Kasi, as I have said, hindi natin pwedeng isolve agad ng isang buo kasi unang-una, dalawa yung kanyang equation. And for this part, at 0 less than or equal t less than or equal 30 seconds. So, ito yung 30 seconds na yan, natakpan. Solving for the velocity. Of course, given an equation S, isa-solve natin yung velocity and kung ano yung masasolve natin sa velocity na yun, yun yung ilalagay natin sa graph. And kung ano naman, from the VT graph naman or from the velocity, kung ano yung masasolve natin doon na acceleration, yun yung ilalagay natin na points sa AT graph. Okay, given an equation, we have S is equal to 0.40 square. And now, isa-solve natin ang velocity. We have the equation V is equal to ds over dt. Ngayon, of course, isa-substitute natin ito. Ito yung value ng S natin. Ayan. So, this is now the derivative of 0.40 square over dt. Now, simple lang gagawin natin. We differentiate. Derivative of 0.4 t square. We have 0.8 t. Now, ito yung ating equation for the velocity. Paano natin malalaman ngayon yung exact value ng ating velocity? Meron tayong given na time. Ito siya. From 0, itong binibilugan ko ngayon, from 0 to 30. Dito natin makikita kung ano yung magiging value, yung dalawang value ng ating velocity na ilalagay natin sa VT graph. For the time 0 seconds, ang velocity natin we have 0.8 times 0. Velocity now is equal to 0. So, ito po yung ating unang value ng velocity when the time is at 0 seconds. Next, for t is equal to 30 seconds. Ayan. Velocity now is equal to 0.8 times 30 seconds. Ang ating velocity now is equal to 24 meters per second. So, ito na yung unang dalawang points. Ito yung unang dalawang points na ilalagay natin sa VT graph. Now, for example, this is our graph. Sulat muna natin. V is equal to 0 when time is equal to 0. And V is equal to 24 meters per second when time is equal to 30 seconds. Now, yan yung unang dalawang points na ilalagay natin sa graph. Pero, meron pa tayong time na etong part na ito. So, tapos na tayo sa first part. Let's say this is A and this is B. Tapos na tayo sa first part. Doon naman tayo sa second part. Yung time na 30 less than or equal time less than or equal 40 seconds. Dito na sa pagitan na to. Itong sinishadan ko na yan. So, ito naman yung ating isosolve ngayon. And sa part na to, iba na yung ating equation. We have given an equation. S is equal to 24t minus 360. So, ito naman yung ating equation ngayon. And then, using the same formula, V is equal to ds over dt to calculate the value of the velocity. So, d derivative of 24t minus 360 over dt. Now, the equation of the velocity ngayon, this is 0 na, and 24 na lang ito. Ngayon, so kanina kasi, itong ginuguhitan ko ngayon, kanina, nasolve natin equation ang lumabas. We have velocity is equal to 0.80 dun sa unang motion natin. Ngayon, dun sa kadugtong na motion niya, ang nakuha natin for velocity is exact value na. Ibig sabihin, ito na po agad yung ating velocity. Ayan. Hindi na natin kailangan pang mag-substitute ng time kasi exact velocity na agad yung ating nakuha. And dahil meron na tayong exact value ng mga velocity natin, we have 0, 24, and 24, pwede na natin ngayong gawin yung VT graph. So, this is the VT graph. Ayan. Ilagay natin yung mga value ng time. Ito yung ating time, yung horizontal axis in seconds. And this is our velocity in meters per second. Now, i-plot natin muna yung mga values ng time. We have 0, and let's say 30, and 40. Ayan, 0, 30, and 40. And for the velocity, meron tayong actually dalawang value lang namin nakuha natin. We have 0 and 24 lang. 0 and let's say this is 24. Now, dun muna tayo. When the time is at 0 seconds, ang ating velocity ay 0 din. So, ibig sabihin, ito lang yung ating first point. Ayan. Next, at the time 30 seconds, ang ating velocity ay 24 seconds. So, ibig sabihin, nandito yan. Ito. So, point na yan. Now, dun sa second motion natin, yung straight line na equation, yung 24t minus 360, nung kinalculate natin velocity, exact value na agad yun natin nakuha. We have 24, ito siya, 24 meters per second. And kapag ganyan, so dito sa 0 to 30, ito yung kanyang line, papaganyan. So, ayan. And then, dun sa exact value ng 24 meters per second na nakuha natin sa second motion, ito po yan, exactly horizontal. Papaganyan yung ating motion. So, ito yung ating graph ngayon. For the AT graph naman. So, for the AT graph, syempre kanina, for the VT graph, sinolve natin yung mga values ng velocity. And now, isosolve naman natin yung mga values ng acceleration. Syempre, hahatiin din muna natin. Doon muna tayo sa unang part ng motion. At 0 less than t less than 30 seconds. To calculate the acceleration, meron tayong formula na A is equal to dv over dt. Diyan natin lalagay. But, wala naman tayong s dito. Ang given sa atin sa problem ay mga equation ng s. Pero, sa VT graph kanina, nasolve na natin lahat ng values and yung equation ng velocity. So, yung unang velocity natin, we have 0.80. Ito ilalagay natin dito ngayon. And now, we have acceleration is equal to derivative of 0.80 over dt. And by differentiation, cancel ito. Ang makukuha natin sa sagot ay exactly 0.8. Wala na pong ibang nakalagay na variable. Saktong 0.8 yung nakuha natin. Ibig sabihin, sana yung acceleration for the first motion dito sa part na ito. So, this is meters per second square. Ito na agad yung ating unang point na ipa-plot sa AT graph natin. Next, for the second motion, at 30 less than or equal t less than or equal 40 seconds. Dito na tayo ngayon sa part na ito. And same process, we have acceleration is equal to dv over dt. The problem is, ano ba yung equation na nasolve natin kanina for the velocity sa second motion? Ang nakuha natin kanina is exactly 24 meters per second na. Wala nang ibang variable na nakalagay. Ibig sabihin, ito na ilalagay natin dito. So, acceleration now is equal to derivative of 24 over dt. And we all know that the derivative of a constant is 0. So, meaning sa second motion natin, the acceleration is 0. Ayan na po yung ating ipa-plot. Now, sulat natin, kapag yung time natin is at 0, acceleration is, eto, 0.8 meters per second square. And yung kapag yung time naman natin is at 30, eto rin siya, 0.8 din meters per second square. But, sa second motion, pag yung time natin is at 30, magzi-0 din siya. So, 0 din ito. Acceleration. And at 40 seconds, eto lang din siya. Pareho lang din na 0. So, ibig sabihin, ang magiging graph niyan ay ganito. This the time. Yung horizontal axis natin, yun yung time in seconds. And this is now the acceleration in meters per second square. Now, ilagay muna natin yung mga points natin. We have, sa time, meron tayong 0, and 30, and 40. And sa acceleration natin, may nakuha tayong dalawang points, 0 at saka 0.8. So, ito na yun. And the 0.8. Let's say, for example, nandyan siya. Now, ipa-plot na natin ngayon. For the first motion, kapag ka 0 yung time, 0 din yung acceleration. Kapag ka 0 yung time, yung ating acceleration ay 0.8. Ito siya. Ayan. And, ganun din sa time at 30 seconds, 0.8 din siya. Ibig sabihin, exactly horizontal lang yung ating graph dito. Ayan. And, at time 30 seconds, nagbago rin yung kanyang acceleration. Ganun sa kanina. Ito siya. 0. Ibig sabihin, bababa siya dito. And at time of 40 seconds, 0 din siya. Ibig sabihin, ito po siya. So, ito yung ating AT graph from the problem, from the example number 1. So, for a slightly clear graph, ayan. So, this is the VT graph and this is the AT graph. Medyo clear ng onte. Next, for example number 2, problem. A particle starts from s is equal to 0 and travels along a straight line with a velocity of, given, again an equation, velocity naman ang given sa atin, t square minus 40 plus 3 meters per second. Where yung t natin is in seconds. So, construct the VT and the AT graphs for the interval 0 less than or equal t less than or equal 4 seconds. So, kanina, sa problem number 1, ang binigay sa atin is an equation of the position ng S natin. Ngayon, ang binigay naman sa atin is the equation of velocity naman. And we are creating the VT graph pa din at saka AT graph. Wala tayong binigay na ST graph. Okay? So, unahin natin, dahil ang equation natin is V, ayan, una natin gawin is yung AT graph. So, for AT graph, ayan, isang time interval lang naman ang kailangan natin dito. So, hindi natin kailangan maghati-hati. Kasi isang buong time interval lang from 0 to 4 seconds, yung in-between na yon. So, we have acceleration formula is equal to dv over dt. Now, yan, meron tayong value ng v na given sa problem. Ito po yan, ito. So, we have acceleration is equal to the derivative of t squared minus 4t plus 3. Now, given the equation of the velocity, isosolve natin yung value ng acceleration over dt. Acceleration now is equal to, we have 2t para dito, and minus 4 na lang, and this is 0 na. So, ito yung value ng ating acceleration in terms of time. Dahil alam na natin yung equation, at hindi naman tayo nakakuha ng exact value for acceleration, kailangan natin isolve with respect to time. So, when time is at 0 seconds, ano ba yung value ng acceleration natin? Acceleration is equal to 2 times 0 minus 4. So, acceleration, when the time is at 0 seconds, we have negative 4 meters per second square. Ito yung ating unang point for AT graph. Next, at time of 4 seconds. So, dalawa lang naman kasi silang given. Acceleration is equal to 2 times 4 minus 4. Ayan, minus 4. Acceleration is equal to positive 4 meters per second square. Alam na natin pareho yung dalawang points ng acceleration. Therefore, we can create the AT graph now. Now, ayan. Ito yung ating AT graph. So, this is 0. Plot muna natin yung mga points ng acceleration. For acceleration, dalawa lang naman. Negative 4 at saka positive 4. Let's say, ito yung negative 4 natin. And ito yung positive 4. Next na i-plot natin is yung time. We have 0. Ito rin siya. And yung 4 seconds. Ayan yung ating 4 seconds. So, ito yung ating horizontal axis na time, and ito naman yung ating acceleration in meters per second square. So, ipa-plot na natin. So, when t is 0, ang ating acceleration ay negative 4 meters per second. Ito po siya, yung point na yan. And, when time is equal to 4 seconds, yung ating acceleration now is equal to 4 meters per second square, positive. So, eto siya. Ayan. Ayan. And then, ipa-plot na natin. This is, ayan. Eto po yung ating AT graph for example number 2. And if we can notice, merong time or merong time na mag-zero yung ating acceleration. Ito yan. Ito kasi ang ating acceleration, itong vertical axis. So, sa time na ito, yung ating acceleration ay 0. So, ano ba yung time na yan? Kasi, kailangan nating malaman yung time na yun because it will have an effect for our velocity. So, paano natin malalaman yung time na yun? Meron naman na tayong equation ng acceleration is equal to 2t minus 4. So, paano natin i-solve yung value ng time na yun na kapag yung acceleration ay 0? Di-equate natin sa 0. Acceleration is 0. Pag yung acceleration natin ay 0, 0 is equal to 2t minus 4, solve for t. Ano yung magiging value ng t natin ngayon? And ang magiging value ng t natin yan is 2 seconds. Ibig sabihin, at 2 seconds, hindi lang niya sinabi sa problem, in between those 0 and 4 seconds, at 2 seconds, may time doon na mag-0 yung ating acceleration. So, that's for the AT graph. Next, for the VT graph. VT graph, yan. For VT graph, Given na sa atin yung value ng, or yung equation ng velocity, eto na po siya. So, hindi na natin pang kailangan mag-differentiate. Eto na agad yung ating gagamitin. So, we have v is equal to t square minus 4t plus 3 meters per second. So, that's our velocity. To calculate for the points of the velocity na ilalagay natin sa VT graph, direct substitute na lang po ang gagawin natin for the time. So, ang time na natin na relevant is yung 0, yung 4 seconds, and yung kanina na 2 seconds. Yan yung 2 seconds na kung saan yung ating acceleration is magzi-0. So, when time is at 0 seconds, velocity natin is equal to 0 square minus 4 times 0 plus 3. Ang ating velocity dito is equal to 3 meters per second. So, ayan. And next, for the 2 seconds, ito muna unahin natin, mas maliit. When time is at 2 seconds, so velocity is equal to 2 square minus 4 times 2 plus 3. Velocity now is equal to 2 square minus 4 times 2 plus 3 is equal to negative 1 meters per second. So that's our second point. And for the last time interval, yung ating 4 seconds, when time is equal to 4 seconds, velocity is equal to 4 square, ito yan, minus 4 times 4 plus 3. Ano yung magiging value ng ating velocity given time 4 seconds? So, ang value natin ay 3 meters per second din, positive. Parang ito. Creating the VT graph. Ayan. So, ilagay mo natin yung points ng time. We have 0. Ito yan. 0, 2, and 4. This is 2. This is 4. Yung horizontal axis natin is the time in seconds. And the vertical axis is the velocity in meters per second. And now, dalawa lang yung ating points for the velocity. Yung ito kasing una at saka panghuli is pareho lang naman. Okay? So, lagay natin, we have negative 1 and positive 1, 2, and 3. Pag yung ating time is at 0 seconds, ang velocity natin is 3 meters per second. Ito siya, we have this one, ito. And kapag yung time natin is at 2 seconds, nun magbabago yung kanyang velocity, magiging negative 1. Ito po siya. Ayan. And finally, this is negative 1 meters per second. Kapag yung time natin is at 4 seconds, yung kanyang velocity ay 3 meters per second. Kapag 4 seconds, ito siya. So, this is our last point. Kung i-graph natin yan, it's more on a parabolic graph, parabolic curve. Ayan. So, ito po ang ating VT graph out of problem number 2, out of the velocity na given na equation. So, ayan, na-solve po natin. Ngayon, kung hindi kasi natin alam itong 2 seconds na to kanina, kung nag-direct tayo na masasolve, wala tayong magagawang ganito kasi parehong positive lang makukuha natin kung ang i-consider lang natin na time is yung 0 at saka 2 seconds. Kaya mahalaga kanina, since nag-0 yung acceleration sa time na yun, baka mahalaga na malaman natin kung anong time yun. So, that's example number 2. And for a slightly clearer version of the graph, ayan. So, the AT graph and the VT graph. For example number 3, an object starts from rest at s is equal to 0 and is subjected to an acceleration shown by the AS graph. So in this problem, ang ating pinag-usapan na is about AS and VS graph. Okay? So, draw the VS graph. VS graph ang ating gagawin. And determine the time needed to travel 200 feet. Okay. Kung mapapansin natin dito sa graph, ayan, there's only one equation. But, dalawang part ng motion ang gagawin natin dito. This one, ito yung unang part natin, from 0 to 300 feet, and from 300 feet to 400 feet. Remember, sa AS graph natin, hindi na time. Wala na tayong time dito. Kanina kasi, kaya VT, ST, tsaka AT. Kasi yung T time, yun. And dito naman sa AS tsaka VS, yung S natin is position. So, this is 0 to 300 feet and 300 to 450 feet na ang ating pinag-uusapan. Now, for the first motion, kasi as I have said, hindi natin pwedeng isolve ng isang diretso agad kasi magkaiba sila ng equation or ng mathematical function. For the first part of the motion, let's say for 0 less than S less than 300. Okay. Meron tayong isang equation. Yung equation na yun nasa second part ng motion nito. So, ano yung gagamitin natin dito sa first part of the motion? Anong equation ang gagamitin natin dyan? Wala tayong equation dyan kasi take note, kung mapapansin natin, ayan, horizontal po yung ating graph dyan or yung ating line. Ibig sabihin, may value na siya agad, exact value. Ito yun, yung 12. So, acceleration is already equal to 12. May value na agad yung ating acceleration. At yung acceleration na yan, yan yung gagamitin natin to solve for the velocity. How can we solve for the velocity given an acceleration? Again, we have the formula. Yung A ds is equal to V dv. Kapag ka nasa VS sa AS graph na tayo, dito na tayo ikot. Okay? Now, we have an acceleration already. Itong 12 na to. To solve for the velocity, we integrate both sides. So, the integral of ADS is equal to the integral of V dv. Ang limits na ilalagay natin dito, syempre of course, yung position natin from 0 to S and dito naman from 0 to V. Yung V na yan naman sa solve natin, yun yung magiging exact value for the point of the velocity na ilalagay natin sa VT graph. Now, solving. Acceleration is equal to 12. 12 na agad ito. From 0 to S is equal to the integral of velocity dv from 0 to V. So, integrating, ilabas natin yung 12 and the integral of ds is simply S na lang. Limits from 0 to S. And then, the integral of V. So, we have V squared over 2. V squared over 2 from limits 0 to V. We are solving for the velocity. The first point sa graph na gagawin natin, sa VS graph na gagawin natin. Now, substituting the limits, we have, dito na tayo, 12S, 12S, ayan, minus 12, yung 0 naman na limit, ayan, is equal to, substitute natin ito, we have V square over 2 minus 0 square over 2. Ito ay cancel, ito rin ay cancel. Ang matitira sa atin, we have 12S is equal to V square over 2. And, masasolve na natin yung velocity kasi meron naman tayong meron naman tayong value ng S, yung ating 300. Ayan po siya yung unang lalagay. Kasi kapag 0 na yung nilagay natin dyan, 0 na rin yung velocity. And kapag ka 300, ano yung magiging value ng velocity natin? So, compute muna natin. We have 24S. O, nilagay ko to doon. Is equal to V square. So, V now is equal to the square root of 24S. Ito yung ating equation ng velocity ngayon. Now, solving for the exact value. At S is equal to 0 feet. Ano daw yung ating velocity? Square root of 24 times 0, di 0 lang din yan. So, ito yung unang point natin. Pangalawang point, at S is equal to 300 feet. V is equal to square root of 24 times 300 square root. V is equal to, calculator, we have square root of 24 times 300. The value is 84.85 feet. So, ito yung ating pangalawang point na ilalagay sa graph. Okay, pero hindi pa tayo tapos kasi unang part pa lang dito ng motion. Dito pa lang to, yan. Itong sinishadon ko na yan. Meron pang pangalawa. Sa pangalawa, for, let's say 300 less than S, less than 450 feet. Meron tayong given na equation ng acceleration. Acceleration is equal to negative 0.04S plus 24. Ang given sa atin is acceleration, but we are solving for the velocity. So, using again this equation, ADS is equal to V dV. We are solving for the velocity. Okay? So, we integrate both sides ulit. Integrate, and now, substituting the value of the acceleration, yung equation natin na negative 0.04 S plus 24 ds is equal to V dV. Ngayon, ang limit natin dito sa left side of the equation ay 0 or 300. Kasi ito na tayo. 300 to 450 na position. And then dito naman, sa velocity natin, ang unang ilalagay natin na limit, meron na tayo na solve kanina. Ito yun. Itong 84.85 kasi nandito siya sa point na to. Now, ang limit natin dito is 84.85 feet to velocity na hindi pa natin alam na yun yung ating isosolve. Pagpalitin natin ito, 24 minus 0.04 S. Ayan, para mas madali tayo mag-integrate. So, integrating, we have 24S and minus 0.04 S squared over 2 limits from 300 to 450. And sa right side na equation natin, we have V squared. Simply, V squared over 2 limits from 84.85 to V na hindi natin alam kasi yan nga ang ating hinahanap. Para mas mailagay natin, dito na tayo sa kabilang page. Sulat mo natin legit equation, we have 24S minus 0.04 S squared over 2, 300. Ngayon, ang ilagay muna natin is simply S lang muna. S is equal to V squared over 2 limits from 84.85 V. Okay, and then substituting the values, we have 24S minus 0.04 S squared over 2 minus 300, 24S, 300 ito, minus 0.04, this is 300 squared over 2 is equal to, we have V squared over 2 minus 84.85 squared over 2. Dito na natin ilagay ngayon. So, calculate. We have 24 S minus 0.04 S squared over 2. And ito naman, calculate natin. The value is negative 5,400 is equal to V squared over 2. And the value is, para dito, we have 84.85 square over 2. Ang value is 3,599.76, or we can rewrite this as 3,600 na lang. Exact value na lang ilagay natin dyan. No? Simplifying, we have 24s minus 0.04 s square over 2 minus 54 is equal to v square over 2 minus 3,600. Now, solving for v, ilagay natin lahat ng known terms natin sa kabilang equation at yung hinahanap natin na velocity sa kabilang equation. Now, by simplifying algebraically, we have v square is equal to 48 s minus 0.04 s square minus 3,600. So, ayan na siya pag ini-arrange. And next, we are solving only for the velocity. So, kailangan mag-read natin yun. So, ang gawin natin, square root nitong kabila. Kumbaga, square root ng both sides para makancel yung square ng v. 48s minus 0.04 s square minus 3,600. So, alam na natin yung equation ng velocity. Pwede natin i-substitute ngayon yung limits ay yung dalawang position natin from 300 to 450. At s is equal to 300 feet. Ang magiging value ng v natin, we have 48 300 minus 0.04 300 square minus 3,600. So, ang value ng v natin is equal to, same value, we have 84.85 feet per second. Ito siya. Ito lang din siya. Same as nung velocity kanina at 300 niya. Next, at s is equal to 450 feet. So, v is equal to 48 times 450 minus 0.04 times 300 square minus 3,600. Ang value ng velocity natin ngayon ay 99.499 or simply 99.45 na lang. 99.45 feet per second. So, eto na yung mga ilalagay natin na points ngayon for our VS graph. Kapag yung S natin ay 0, ang ating velocity ay 0 din. Kapag yung S natin ay 300, ang ating velocity ay 84.85 feet per second. And when the position is at 450 feet, the velocity is 99. Let's say 0.5 na lang feet per second. Ito na yung ating ilalagay for the VS graph. So, this is the VS graph. Ayan. Locate mo natin yung points is 0. The horizontal axis now is the S in feet. And ito naman yung ating V in feet per second. So, 0. And yung isang position natin, we have 300. Let's say ito yun. 300 and 450. Now, for the velocity, meron tayong tatlong nakuha, 0, 84.85 at saka yung 99.5. This 84.85 at saka yung 99.5. No? I-create na natin ngayon. Kapag 0 yung velocity, eto, 0 lang din siya. Kapag yung S natin is at 300, yung ating velocity ay eto. So, nandito tayo. Kapag yung S natin is at 450, yung ating velocity is 99. Ayan. So, eto ngayon yung ating VS graph. So, let's say, papaganyan siya. Kasi, hindi straight line to. Unang-una, makikita natin dun sa equation. Ang equation nito, we have V is equal to 4.9 S raised to 1 half, or in-arrange ko lang, ito yung kanina na equation na square root of 24S. Ayan yun. And then, let's say papaganyan na to. Ang equation naman nito kanina, we have V is equal to the square root of negative 0.04S square plus 48S minus 3,600. So, ito yung ating VS graph for the example number 3. And for a clearer version of the graph natin, ayan. So, this is the VS graph. Pero hindi pa tayo tapos sa example number 3 kasi meron pa tayong isang hinahanap. Determine the time needed to travel at 200 feet. Ibig sabihin, yung 200 feet na yan, nandito yan sa part na to. Ito. Nasa first part of the motion siya. Ibig sabihin, kung isosolve na natin yung time, ang gagamitin natin na equation na yung equation na nakapaloob dito. So, ano yung equation na yun? Yung equation na yun ay yung V is equal to the square root of 24S or yung 4.9S raised to 1 half. Okay. Now, solving for the time. To solve for time, meron tayong formula for the velocity na V is equal to ds over dt. Solving for time ngayon. And then, i-arrange natin, we have dt is equal to ds over v. So, ilagay na natin yung value ng v. dt is equal to ds over, ito na lang gamitin natin. We have 4.9 S raised to 1 half. And then, to solve for t, we have to integrate. Integrating both sides, dito na natin ilagay. So, the integral of dt, ang limit na ilalagay natin of course is from 0 to t na hinahanap natin na hindi pa natin alam. Is equal to the integral of ds over, mas madali, itong 4.9 na to, ilagay din natin dito, cross multiply natin. So, this is 4.9 na. Yan, 4.9 dt. So, is equal to the integral of ds over s raised to 1 half. Ang limit natin is from 0, and ang sabi sa given ay 200 feet daw yung na-travel niya. 200. Solving for the time now. Pero, gawin muna natin is integrate both sides of the equation. So, we have the integral of 4.9 dt is simply 4.9 t na lang, limits from 0 to t, is equal to, lipat ito, mangyari dito, para mas madali, magiging, yan, s raised to negative 1 half ds. Para mas madali. And then, mangyari pa sa kanya ulit, we have s negative 1 half plus 1 over negative 1 half plus 1. So, ang mangyari ulit sa kanya ay s raised to 1 half na over 1 half. Okay, lagay natin dito. We have s raised to 1 half over 1 half. Limits natin from 0 to 200. Okay, simplify pa natin. We have 4.9t 0 to t is equal to, ito kasi pwedeng gawin natin dyan, lipat natin doon, 2 na lang siya, 2s raised to 1 half, limits from 0 to 200. We can now substitute the values or the limits. 4.9t minus 4.9 times 0, so wala na yan, is equal to 2 times value ng s natin, 200, 200 raised to 1 half minus 0 na rin siya kasi ito yun. So, solving for the value of time, 4.90 is equal to, we have 200 raised to 1 half. Lipat natin. Divide both sides by 4.9. 4.9. Cancel. T now is equal to 5.772 seconds. So, ito yung time daw. Yan yung time kapag yung ating object ay nasa position na 200 feet from the starting positions. For example number 4. Sa example number 4, kabaliktaran naman siya ng example number 3. Kanina, given an AS graph, gagawa tayo ng VS graph. And now, for example number 4, for our last example, gagawa naman tayo ng AS graph out of the VS graph given. So, the VS graph of a particle traveling along a straight road is shown. Ito nga yan. Gagawa tayo ng AS graph. So, yung VS graph natin dito is divided into two parts. So, dalawang computation ulit ang gagawin natin. First part and the second part. And each part, given a straight line equation. So, una, we have 0.s plus 5, 0.1s plus 5, and negative 0.04s plus 19. Now, kailangan natin is the value ng acceleration kasi yun yung points na ilalagay natin to create the AS graph. For, let's say 0 less than s less than 100 muna tayo. To find the value of the acceleration, syempre, ang gagamitin pa rin natin na formula is yung ADS is equal to V dV. And solving for the acceleration is equal to V dV over ds. But, the problem, ang given sa atin is the velocity. Paano natin masasolve yung acceleration? We have given na value of the velocity na yung unang gagamitin natin is 0.1s plus 5. Ito na yun. Kaya lang, kailangan natin ng value ng dV over ds. So, ang gagawin natin dito sa V na to, we differentiate with respect to position. dV over ds. Derivative ng 0.1s, we have 0.1 and this is 0. So, ito na po yung ating dV over ds na ilalagay dito. We can now find the value of the acceleration. Acceleration is equal to 0.1s plus 5 times 0.1. So, acceleration is equal to 0.01s plus 0.5. So, ang nasolve natin is an equation. And then, to find the exact value of the acceleration, we need to substitute yung ating 0 and yung 100. At s is equal to 0. Acceleration is equal to 0.01 times 0 plus 0.5. Acceleration now is equal to 0.5 feet per second square. Ito yung unang value ng acceleration natin. And now, dito natin lagay. At s is equal to 100. So, acceleration is equal to 0.01 100 plus 0.5. Acceleration now is equal to 1.5 feet per second square. So, ayan ang ating value. For the next part of the motion natin, doon na tayo sa 100 less than s less than 350. Or pwede rin lalagay natin dito yung nakaganyan. Ayun. So, meron tayong given equation for the second part of the motion natin na V is equal to negative 0.04s plus 19. And same equation ang gagamitin natin to find the equation or the value of the acceleration. ADS is equal to V dV or simply V dV over ds. And to find ito, kailangan natin malagay yung values nito. Ang v natin is simply ito na. To find the dv over ds, we integrate this equation. So, we have negative 0.04 and ito ay 0 na. So, ito na agad yung ating value. So, acceleration now is equal to negative 0.04s plus 19 times ito na negative 0.04. Yung ating acceleration is equal to 0.0016 positive s minus 0.76. So, ito yung ating equation. And now, ilalagay na natin yung values. At s is equal to 100. Acceleration natin is equal to 0.0016 100 minus 0.76. Acceleration natin now is equal to 0.0016 negative 0.6 feet per second square. Ayan yung ating susunod na points. And then at s is equal to 350. So acceleration is equal to 0.0016 350 minus 0.76. Acceleration now is equal to negative 0.2 feet per square second. Alam na natin lahat ng points ng acceleration, and of course, alam na rin natin yung lahat ng points for the position. We can now create the AS graph. So for the AS graph, lipat na tayo sa kabila. When the position is at 0, ang ating acceleration ay 0.5 feet per second square. Kapag yung position naman natin ay at 100 sa unang motion, we have acceleration of 1.5 feet per second square. Kapag yung ating position ay 100 feet, second motion, we have the acceleration of negative 0.6 feet per second square. And finally, for that 350 feet na position, acceleration natin ay negative 0.2 feet per second square. Ito yung mga points natin na ilalagay sa AS graph. This is the AS graph. Ang lagay muna natin is yung sa positions. This is the position in feet, and this is the acceleration in feet per square second. So sa position we have 0, we have 100 and 350. This is 100, this is 350. Now solving, plotting the acceleration points, we have 0.5, say ito siya, 0.5, 1.5, negative 0.6, extend natin, negative 0.6, and negative 0.2. Ayan, let's say, ito na yung atin. We can now plot the graph. So, kapag ka yung S ay 0, ang acceleration ay 0.5. Ito siya. Kapag yung S ay 100 feet, 1.5 ang ating acceleration. So, ito yan. And then, sa second motion natin, kapag yung S natin ay 100 feet, magiging negative naman yung kanyang acceleration, which is 0.6. Ito siya. And finally, kapag yung position natin is at 350 feet for the second motion, meron tayong 0.2 negative na and acceleration. So, ipa-plot na natin. We have, ayan, paganyan. And bababa siyang paganyan. And finally, paganyan. Ayan po yung ating AS graph for example number 4. So again, for a slightly clearer version of the graph, ayan. And that's all for today's video, guys. So next part for the dynamics will be about the curvilinear motion. So thank you for watching and see you on the next video.